So welcome back. We're going to talk about free energy right now. And free energy, well, when I say free energy, thinking more about this term for the system, change of free energy of the system, has a relationship with standard free energy for a system as well as the reaction quotient. And typically, and this has been mentioned in some of the other videos as well, typically it's change to free energy that's going to be the best indication of spontaneity for the system. Standard free energy has more of a relationship with the equilibrium constant. So with that idea in mind, if we know standard free energy for the system and we have enough information to calculate a reaction quotient, we can figure out what the system as it is providing in terms of free energy or taking up in terms of free energy. And because we're talking about an energy-related equation, the R value is going to have to be 8.3145 joules per Kelvin mole to work this out. So because the units for R, when we get our answer for delta G, we're going to have a joules answer. That also means when we plug in our value for the change to standard free energy, we're going to have to use a joule version of that value. Typically, standard free energy is given in kilojoules per mole, which means that we're going to need to make an adjustment to that value before we plug it in to the equation. So with that in mind, we can take a look at a pretty typical type of question here. So it says that so the reaction shown below, question is going to be, is it spontaneous when oxygen is at 2 atmospheres and the reaction is run at 15 degrees Celsius. So the interesting thing here is that these conditions are not standard conditions for thermodynamics. We're not looking at 25 degrees Celsius and 1 atmosphere. We have a brand new set of conditions here. And so, as this line says, this equation here gives us the ability to calculate free energy for a process at pretty much any temperature or pressure because of the relationship that's existing here. Now again, remember that in order to use Q with pressure, everything that's going into the Q statement has to be a gas. 2 solids, 1 gas, that's going to be what's part of our reaction quotient only, and so we can calculate Q based on pressure. So, as we look here, we're going to have the following idea. So delta G is equal to change in standard free energy plus RT, natural log of Q. And so as we're looking at this situation, we have delta G is going to equal, remember this statement, we have to convert this to joules, so negative 754,000 plus 8.3145 times, maybe we'll do this, we'll bracket all this off, we'll do this, times, and the temperature, 273 plus 15 should put us at 288, and then times the natural log of, and so now we got to make sure that this gets set up correctly. We're looking at 1 over 2 because oxygen being a reactant should be on the bottom, so 1 over 2, and close that off, and then final bracket that. So we've got a fair amount of information going on here. So let's take a look here. Got negative 754,000 plus the quantity. Looks like I'm going to go double parentheses, 8.3145 times 288. Close that one down. Open up a fresh set of parentheses. We're looking for natural log of 1 divided by 2. Close that parentheses. Close that parentheses. And close the parentheses. And we've got what appears to be an increase. We're now going to be at negative 755,658 And given 3 sig figs, could probably take this to 3 sig figs and call it negative 756,000 joules. And so what happened is, because we had an increased pressure to the reactant side, right, that's a change that's going to be decreasing the Q value, right? So we essentially have a situation where Q is likely going to be less than standard conditions at the very least, right? So Q creates a situation where it's less than standard conditions, maybe would be a better way to put it. And so with that, right, because essentially 1 over 2 is less than 1 over 1. So with that, the system is going to be encouraged to push more towards the product side. How do we show a system that's pushing more towards the product side? Well, we have a more negative delta G value. So essentially that's how this equation works. It allows us to take a known standard free energy and turn it into a free energy at some new temperature and or pressure or concentration. So hope that this makes sense for you and is helpful putting it to use for yourselves.